Someone is praying for you. Someone is praying for you. So when it seems you're all alone and your heart will break in two.
Welcome to our lessons on ordinary differential equations. In this lesson, you're going to take a look at linear combination and linear independence of solution. Let's start by looking at linear combination of two or more functions. Suppose that we have the functions y1 and y2 being both solutions of the homogeneous differential equation, second order differential equation. Then since these functions are solutions, we are saying that the constant c1 multiplied by the solution y1 plus c2 multiplied by the solution y2 is a solution to this differential equation 1. And any constant c1 and c2 for all real numbers or all numbers holds. The function we are having here as the solution 2 is what we call the linear combination of the functions y1 and y2. So we linearly combine these solutions. So let's look at this. If you are given that y1 is sine x and y2 cos x as solution to a second order linear differential equation, we want to show that the linear combination is also a solution. So what we are saying is that since y1 equal to sine x is a solution and y2 equal to cos x is a solution of y prime prime plus y equal to 0, then our linear combination equals y of x equals c1 sine x plus c2 cos x is a solution. So you want to look at whether this linear combination is a solution, and we just need to take the first, second derivative and then we put them inside this. So if I call this one equation 1, the first derivative y prime of x will give us c1 cos x minus c2 sine x. Then when you take the second derivative, you're going to get negative c1 sine x minus c2 cos x. To verify whether it's a solution, we want to find out whether this identity holds that y prime prime plus y is equal to 0. We know y prime prime is minus c1 sine x minus c2 cos x. And then y is plus c1 sine x plus c2 cos x. And when you put these two together, you realize that you get 0. So we are saying that the linear combination is also a solution. But this will cancel this, and this will cancel that, so we get 0. Let's look at the linear dependence and the linear independence of functions. We are saying that a set of distinct functions, y1, y2 up to yn, are said to be linearly dependent in a given interval I if there exists n constants, c1 up to cn, in which not all of them are 0. It means some may be 0, but others may not be 0. Such that in that interval, the linear combination here is going to give you 0. What it means is that we know for sure that if c1, c2, and cn are 0, this is going to be 0. But if not all of them are 0, all the c's are 0, but you end up, the linear combination end up giving a 0, then we say that these two functions, y1 up to yn, are linearly dependent. In another way, if you can write a linear combination and express one of the functions as a function of the other, then we say that the functions are linearly dependent. Once you can express one of them as a function of the other. The second definition have to do with linear independence. And it says that if y1, y2 up to yn are said to be linearly independent in the given interval, if the existence of this identity, that's a linear combination code, implies that all the c's must be 0. In other words, before this whole function is 0, c1, c2 up to cn must all be 0. Otherwise, it can never be 0. If something like that happens, then we say that the functions are linearly independent. So let's pick an example here. We want to verify whether y1 equal to sine x and then y2 equals to cos x are linearly independent. So what we do is that we say that the linear combination of them c1 sine x plus c2 cos x should be equal to 0. And we want to find out whether we can get any value for c1 and c2 apart from c1 being 0, c2 being 0, so that this equation be 0. And you can see that no matter any number you can pick, from negative infinity to positive infinity, none of them will make it 1 except when c1 is 0 and c2 is 0. So it means that for this to be 0, c1 should be equal to c2 and should be equal to 0. Because even if you decided to pick within the interval some values of x, assume you pick x equal to, let's say, 0, you're going to get sine 0 to be 0, cos 0 to be 1, so you're going to get c2 being 0. If you pick x to be equals, let's say, pi on 2, sine pi on 2 is 1, that will give us c1, and then cos pi on 2 is 0, so c1 also be 0. So no matter what you do, c1 and c2 must be 0 for this linear combination to be 0. And for that reason, we are saying that y1 and y2 are linearly independent. So let's see how we go through these few examples here. So let's start with the first one. When we find out whether these functions are linearly dependent or linearly independent, so we write a linear combination of them c1 sine squared x plus c2 cos squared x plus c3 equal to 0. So c1 multiplied by sine squared, c2 multiplied by cos squared x, and c3 multiplied by 1. Now, besides c1, c2, c3, when they are all 0, everything will be 0. But apart from that, you can realize that if c1 is 1, c2 is also 1, and c3 is negative 1. This is going to give us 0 because you're going to get sine squared plus cos squared x, which will give us 1 minus the 1. So apart from 0, 0, 0, at least we have made money to prove that another set of values will give us 0. And for that reason, we are saying that y1, y2, and y3 are linearly independent. Let's pick this one too. y1 is 3x plus 12 over 5. y2 is 5x plus 4. So the linear combination is c1 times 3x plus 12 over 5 plus c2 times 5x plus 4 equal to 0. So we want to see how we can find our c1 and c2. We know when c1 is 0 and c2 is 0, everything is 0. But is there other values? That's what we want to check. So if you expand these functions, you're going to get 3c1x plus 12 over 5c1 plus 5c2x plus 4c2 equal to 0. Now I want to group our items by bringing all the x into one umbrella. So you're going to have x multiplied by 3c1 plus 5c2. Then we have plus, and this ones two are coming here, so we're going to get 4c2 plus 12 over 5c1. So with this, we just want to do comparison of coefficients. So we compare coefficients. You can see that on this side here, everything is 0. So it means that there's nothing multiplied by x. That means 3c1 plus 5c2 is equal to 0. And this side 2 is a constant, and everything here is 0. So that means 4c2 plus 12 over 5c2 is going to give us 0. So we need to solve these two equations simultaneously. But if I call this one equation 1, equation 2, if I multiply equation 1 by 4, I'm going to get 12c1 plus 20c2 equal to 0. And if I multiply equation 2 by 3, so equation 2 by 3, you're going to get the same 12c1 plus 36 over 5. 36 over 5, c2 equal to 0. Now when you subtract 1 from the left, I'm subtracting according to equation 3, equation 4. So if you subtract 3 from 4, You're going to get 36 over 5 C2 minus 20 C2. This is C1. 36 over 5 C1. 36 over 5 C2 minus 20 C2. So when you do the subtraction, you're going to get here to be 0. So when you do this, you're going to get 36 minus 40, which is 4 over 5 C2 equal to 0. Okay, so when you solve this, you're going to get C2 to be 0. And if C2 is 0 and we substitute in 1, that means 3C1 is also 0, and that means C1 is 0. So that means apart from 0, 0, none other number can make it. Therefore, we are saying that Y1 and Y2 are linearly independent. Let's pick the third one here. So we're going to have C1x plus C2x squared equal to 0. Now, we have been given a certain interval which contains 0. So we can use any values on the interval to check. So when x equals -1, we can have negative C1 plus C2 equal to 0. When x equal to 1, you're going to have C1 plus C2 equal to 0. If you add the 2, you're going to get 2C2 equal to 0 with C2 equal to 0. If C2 is equal to 0, that means negative C1 is also equal to 0 and C1 is 0. So this one also shows that both of them are 0, and therefore the functions y1 and y2 are linearly independent. Thank you for watching.